Thank you. I'd like to thank the organizers for inviting me to come talk today. My talk is going to be divided today into a couple of parts. I'm going to talk a little bit about the opportunity and the challenge of integrating bioinformatics into life sciences education. I'll then talk a little bit about our network, the network for integration of bioinformatics into life sciences education. Then I'll talk about our recent work on determining what the barriers are to integration, and then I'll try and sum it all up. It's been a nice morning so far, hearing about a lot of different projects and hearing about a lot of different issues that people are confronting. So I think some of the stuff that I'm going to talk about will sound pretty familiar to you. So the opportunity and the challenge. We're experiencing a revolution in biology research with the advent of big data. I don't think that's a surprise to anybody. But we also know that the skills necessary to analyze these data are not routinely taught at the undergraduate level in biology and life sciences. So what that means then is students are leaving college underprepared for advanced study in biology, and I would argue that they're leaving also underprepared for changes coming to medicine. And they're underprepared for many technical jobs in the workforce. So I'm, as Dan said, a professor in the biology department at Georgetown. My biochemistry class, because we have a lot of pre-meds, gets about 150 students a year. On the other hand, my bioinformatics class gets about 10 students a year. So somehow we're not getting the message to the students to say, look, this is really important for you. On the other hand, maybe there needs to be some messaging about do they really need to take organic chemistry and physics and things like that in order to prepare for medical school. So we've got a little bit of a problem here, right? It's been estimated that we're going to need, in the United States, about 1 million more people who are trained in STEM, science, technology, engineering, and mathematics, in the next 5 to 7 years. A very influential report from the President's Council of Advisors on Science and Technology called Engage to Excel, that's getting a little bit old now. This is from the previous administration, not the current administration, has said that of the total U.S. workforce, people with non-STEM jobs that do not require STEM skills are going to become an increasingly small fraction of the workforce. So students need to be trained in STEM, but we're not doing a super duper job of that at the moment. Some other data that I pulled from the PCAST report. This is showing the total number of bachelor's degrees, the total number of associate's degrees. This was missing off their legend here. The total number of STEM bachelor's degrees and the total number of STEM associate's degrees. And those in this representation look pretty flat, but if you look at them instead in the fraction of total degrees conferred, what you see is that the trend actually is going down. So despite the fact that we need more students to be trained in STEM over the coming years, the bachelor's degrees and associate's degrees that we're conferring, we have an increasingly smaller fraction of STEM degrees. So, what are some things we can do to kind of allay this rising tide? We know from a lot of research that research experiences for students, and we've heard a lot about those this morning, are HIP, high impact practices for education. And this is coming from repeated work from the National Survey on Student Engagement. We also know from a nice paper that came out a couple of years ago now from the Freshman Research Initiative at the University of Texas at Austin, this Rodenbush et al. Paper, that research experiences positively impact student retention and promote increased graduation rates. We also know that research experiences positively impact retention of underrepresented minority students in STEM. And this is coming from a National Academy of Sciences report from 2015. research experiences enhance interest in graduate level training, and research experiences enhance future earning potential of students. So for all these reasons, we ought to be encouraging our students even early on to get involved in research. And we've heard some examples today about how to flip the classroom, get students involved in research in the classroom. For many students, though, their experience with research looks more like this, right? So this is kind of a typical research experience where an older member of the laboratory, graduate student, postdoc, maybe even the faculty member, is working one-on-one with someone who doesn't have very many skills yet to try and get that person up to speed. And we know that for those students that get to take part in those kinds of experiences, that it's really effective. I mean, from my own experience, being able to work in a laboratory really cemented my desire to go to graduate school. So the problem is that we don't really have the capacity. Not everybody has the opportunity to do this kind of one-on-one mentored research experience. The other problem is that for many students, they don't actually get involved in this kind of research until they're juniors and seniors in college. And the problem then is that some of those students who might otherwise have stayed and become STEM graduates have already trickled away. Because we know that most students actually get their start at community colleges now. About 50% of students start at community colleges. And what happens with those students is if we don't hook them then they're never going to stay in the pipeline. So what I'm saying is that independent research experiences, like the ones that probably many of us experienced as we were coming up, are great, but these are occurring outside of the classroom. So can we build more research experiences into formal classwork? And so this idea that's kind of bubbling up in the education world, this idea of cures, classroom undergraduate research experiences. And can we build them in earlier in a student's career so that we can capture students' interest, keep their interest, and then have them be part of this STEM workforce going forward? I was talking to one of my colleagues yesterday, and we both had the experience with our children that if they have one bad experience in high school or college, they're done, right? They don't want to engage anymore because it's not for them. Some of those students probably still have interest in STEM fields, but we're not making it easy for them to stay. So I would argue then that bioinformatics might be a way to have students engage in authentic research. And what I mean by authentic research was captured, I thought, really nicely by David Asai at the National Academy of Sciences convocation on undergraduate research, where he said that authentic research experiences are ones where the outcome is unknown and the outcome matters to the scientific community and to stakeholders. So bioinformatics may give us a way to think about getting students involved in research earlier in a way that is both cost-effective. There are lots of data available. There are lots of tools available. You can do a lot of interesting bioinformatics explorations with a computer that has an internet connection. So it's relatively cheap to get lots of students to be involved in experiments like this. And the experiments can be performed pretty rapidly, right? It's not like you have to wait for the enzyme to come in from New England biolabs before you can do the next part of the experiment, right? So what are we going to do about this? One avenue that might be productive is one that we're trying to work on called NIBLSE, the Network for Integration of Bioinformatics into Life Sciences Education. And if you join us, you can get a cool shirt like mine. So what we are, who we are, we're a research coordination network for undergraduate biology education. Our funding has come from the National Science Foundation. This was founded in 2014 with an incubator grant, and that gave us some seed money to kind of get our act together. And then since 2015, we've had a full RCN award. And so what I'm going to tell you about are a little bit of the goals of NIBLSE, and then I'm also going to tell you about a big survey that we conducted recently and some of the findings from that survey. Okay, so our long-term goal then is to achieve full integration of bioinformatics into undergraduate life sciences education. I think the folks in this room would all agree that this is a worthy goal, and we hope that you'll join us in trying to achieve this goal. One of the things that actually struck me as I was listening to some of the talks this morning is that lots of folks are doing efforts along these lines, but kind of within their own institution, and not making that material available necessarily to the bigger community. So I think we can all help each other by sharing our resources. So I hope we can maybe have a little bit of discussion about that at the end of my talk. Okay, so we have 4 major goals, and I'll go over these fairly quickly. What we're trying to do is establish NIBLSE as a permanent network of investigators dedicated to accomplishing the long-term goal of integration across life sciences education. In order to do that, we're drawing on the expertise of the NIBLSE membership, and there are a bunch of folks in the room here who are part of the NIBLSE group. Bill Pearson, Bill Taprich, Mark Polly, Bill Morgan. Did I miss anybody? I think I caught everybody. So right now we have about 70 members. Is that what we decided last night? Okay. About 70 members of the group. We're looking to grow the membership. So, so if you're interested, after you hear me talk, and Bill Morgan is talking later this afternoon, if you're interested, let one of us know. But one thing we were trying to do was identify a list of core competencies in bioinformatics for undergraduate life sciences education. So I'll talk about that very briefly, and then Bill's going to touch on that some more. We're also trying to identify and vet assessment tools that align with the core competencies that we've developed. And then finally, we're trying to organize and simplify the dissemination of curricular materials, assessment tools, and professional development resources that align with the core competencies. And that's the bulk of what Bill's going to be talking about. So, okay. So as a first premise, we had our own ideas about what the core competencies should be. So this is the initial group of people who came together in about 2015, 2016. And we realized, though, pretty quickly that we needed more input from the community, from the broader community of life science educators. And so in order to do that, we decided that we were going to do a large survey of life sciences educators. So we conducted a nationwide survey. We developed and deployed the survey over the spring of 2016. The survey was sent to individuals in various existing networks, as well as life science faculty emails that we purchased from a mailing list. So we sent the link to the survey to about 11,000 people, and we got about 1,200 responses, 1,300 responses back. I should emphasize that this is one of the largest, probably the largest survey of its type. And so we feel like because we've touched about 1%, 1 to 2% of the life sciences faculty in the United States, we feel like we have a reasonable representation of some of the concerns of the broader community. So in terms of survey responses, this is showing the continental United States. We also had people from Hawaii and Alaska who answered the survey, although that's not shown on the map here. The circles show where the survey respondents were located, and then the darkness of the state is showing how many responses from that particular state. So we did have good representation across the United States. We have one person in South Dakota and one person in West Virginia, but they're covered, right? So In terms of the survey responses, we did collect some demographic data, and I'm going to show you a little bit of that now and then a little bit of that in a little while. The survey responses were pretty well equal in terms of males and females. The race of the respondents was overwhelmingly white, and I'm going to come back to that at the end of my talk. Overwhelmingly non-Hispanic or Latinx. And then we asked the question about whether or not the faculty member was teaching at a minority-serving institution. Most people said either minority or non, but there was a large fraction of people who didn't know whether they were teaching at a minority-serving institution. Whether it was they didn't know or they didn't bother to answer the question. I can't distinguish between those two possibilities. But that's one thing that we want to explore more deeply, and I'll come back to that also later. Okay, so the core competencies. At the outset, we felt like there wasn't an agreed upon set of competencies for bioinformatics for biology students, and so that was one of the things that we set out to do. So we initially came up with a list of 15, and then we asked the survey respondents to what extent they agreed with those 15. Those were then evaluated and combined, so we ended up with a set of 9 competencies. I'm not going to spend too much more time talking about this because the competencies papers just came out, and so the reference is here if you want to take a look at it. Bill is going to talk about it a little bit more later this afternoon, but I'm not going to say too much more about it. So what I was more involved in was thinking about the barriers to integration. So in addition to having these questions about the core competencies and a lot of demographic questions and things like that, we also asked questions about to what extent are you incorporating bioinformatics and what kind of training you've had and that kind of thing. So what I'm going to do is talk about the barriers information that we learned, kind of the broad overview, and then I'm going to pick out some of the interesting facts that we're hoping to follow up on a little bit. Okay, so when we ask the question, do you agree or not, yes or no, that bioinformatics should be integrated into the life science curriculum, 95% of people agreed with that, so yay, win. However, only 36% of faculty report having achieved integration. And by that, what we meant was teaching a standalone bioinformatics course or having some bioinformatics in existing courses, right? We didn't define that. So we've got a ways to go, right? Somebody made the comment this morning that we need to get students to be more involved in the math part of bio. I would argue that we need some of the faculty to be more involved in the math part of bio. And I think this statistic here kind of represents what's going on there. So, and I'll have more to say about that coming up. The survey included several open-ended questions about barriers. When we initially thought about this, we didn't want to put words in people's mouths. We just kind of wanted to see what bubbled up. And so kind of what bubbled up is what I'm going to spend the rest of my time talking about. So today I'm only going to show you the data from the first question we asked. There were a total of 4. What we realized when we looked at the responses were that 3 of them were kind of repetitive in terms of the answers we were getting. So we decided to focus most of our efforts on this first question because this is the one that most people answered. So in your opinion, what do you think are the most important challenges currently facing those educating undergraduate life sciences and bioinformatics? And 60% of the about 1,300 people answered this question. In terms of the methods for this, we did keyword analysis. So 2 groups, one at Georgetown and one at University of Florida, looked at the comments, tried to pick out key themes. We talked about it a lot. We agreed on the key terms to bin by. And then the folks at the University of Florida, under Eric Triplett, who's also a member of the leadership team for NIBLSE, did a very granular analysis of all of the keywords. And so we counted those up, and that's the data that I'm going to show you. We put these pieces of information into super categories, and so this is the ones we came up with were faculty issues, student issues, and curriculum issues. And then we had categories within each super category. We had a very large discussion about whether it should be categories and subcategories or super categories and categories, but I lost. So these are the ones that were the primary ones that people mentioned. Does anybody want to say what they think is the one that came up the most?
Number one.
Faculty? Okay. Which one of those faculty things? Number one? You are correct. Yes. So, I'm not going to show you all the data. There's a preprint available on bioRxiv that you can get to if you want to dig into this more. And I encourage you to do that and then get in touch with us and let us know what you think. So, so this is really kind of the broad view of what happened here. 24% of those 700 and some people said faculty issues, lack of expertise and training. That's why they are not incorporating bioinformatics into their teaching. A lot of people also said student issues, lack of background skills and knowledge. Student issues, lack of interest. That to me sounds like we're not doing a very good advertising job, and I'm as guilty of that probably as anybody, given the 150 in biochem and the 10 in genomics. Faculty issues, lack of time. Curriculum issues, we decided that term lack of integration wasn't a good way to explain what we meant there. When we went back and looked at the comments, really what it was communication across disciplines. So integrating biology with computer science primarily was what we meant by that. So we're going to change the header there. And then also people complained about too much content. A common thing that people would say was, what am I supposed to leave out? There's too much stuff in there already. So I think we would argue that you can teach a lot of biology through the lens of bioinformatics. If we think about Bill Pearson's talk, you know, BLAST is a great way to talk about evolution. BLAST is a great way to talk about central dogma, right? So you can talk about biology through that lens, I think. So we need to be a little more creative about how we do that. We asked the respondents their Carnegie classification of their school. So community colleges, associate's granting degrees, four-year colleges, bachelor's degrees, master's granting, and then doctoral institutions. So when we stratify the data, the responses on that demographic, we learned something kind of interesting. So this slide is a little busy, but I'm just going to point out a couple of features here. Faculty at doctoral institutions are the ones that complain about training the least, okay? Whereas the people at baccalaureate institutions are the ones that complain most. And that kind of makes sense, right? If you're at a four-year institution and you're tasked with teaching micro and anatomy and physiology and bioinformatics and maybe, you know, intro bio, you don't have time to kind of get up to speed on all this other stuff that's happening really quickly in the research world. On the other hand, when we talk about this lack of background and skills knowledge of the students, the faculty's perception of the background and skills, when we looked at the comments more deeply, what we realized was that the doctoral faculty complain about this the most. But when you dig into the comments, what they're saying is, my students don't have enough stats and computer science background. whereas the associates and bachelor's folks are saying, my students need remedial math. So we've got this huge spectrum here of abilities, and what, you know, we need to think about what we can do to float all boats here. One other thing that was a little puzzling was the lack of interest seemed to be more in the master's granting. I have no explanation for that. We'll just let that one hang. The other thing that came up quite a bit, especially for the bachelor's folks, was this idea of quickly changing technologies. It's very hard, again, when you're busy with a bunch of other stuff, to try and keep up with all of the changes that are happening in the research world. Are there ways that we can help faculty do that? Okay. We also stratified based on when people got their degree. There were a couple people who had gotten their degrees back in the 70s. Most people are, you know, in here. There were a couple people who had gotten their degrees pre-1970. I think somebody had gotten their degree in 1955. We left those folks off this analysis because there weren't very many of them. So, and then the 2010 cohort was really 2010 to 2016. Okay. So if we stratify on the year the terminal degree was earned, these are the results that we see. So the newest faculty, the youngest faculty, are the ones that have had the most formal training in bioinformatics. That makes sense. When I went to graduate school, bioinformatics kind of wasn't a thing yet. I'm a molecular biologist and biochemist. I'm not a bioinformatician by training. So these folks have a lot more training than people who were trained back in the 80s and 90s. That makes sense. What was striking to us, though, was that these faculty are integrating bioinformatics at the lowest rate compared to everybody else. So that was weird. My facetious interpretation of that, which my colleagues kind of didn't agree with, was these folks are getting stuck with intro bio, and they're not being allowed to teach bioinformatics or things that are more in their wheelhouse. I'm not sure that's the correct explanation, but it is one of the things that we want to explore in a little more detail. Okay. We also stratified by whether or not they said they taught at a minority-serving institution. And for those faculty, they report integration at a lower rate than non-minority-serving institution faculty. So again, this is something that's interesting that we want to explore in more detail. If people reported that they themselves are underrepresented in STEM, these faculty report training barriers at a rate that's about twice what I hate this term, non-URM. Can we just call them RM, represented? Anyway, the non-URM faculty. So those also were pretty intriguing results. The caveat with this one in particular, though, is that we only had a very small number of faculty who identified as as underrepresented minority. So again, that's another observation that we'd like to go back and understand more about. Okay, so what are we going to do with all this information? Job one is to get the paper out there, so we're working on that pretty hard. We're also in the process right now of developing a follow-up survey to explore these barriers, and especially the ones of the minority-serving institution faculty and the underrepresented minority faculty. Equity and diversity is a big issue on our campus right now. It's probably on yours too. It's bubbling up from underneath. And so we'd like to know how we can get more students from underrepresented minorities in the pipeline. And one good way to do that is to have role models for them. So if we can get more faculty to feel comfortable integrating bioinformatics, then their students can also be part of this. We are looking to build our resources that are available on the Cubes Hub website. And again, I'm going to point to Bill Morgan, who's talking about this in more detail at 4:40 this afternoon. We're building assessment tools that map onto our core competencies, our 9 core competencies. And this is the work of Liz Dinsdale and Bill Tapperich. And so that's what we're working on right now. So again, if you'd like to join the network, these are some of the things that we're working on right now. So to summarize all the things that I've said so far, and actually this is the end of my talk, we are hoping that bioinformatics provides a way to get more students involved in research. We have great evidence to suggest that undergraduate research is great for students, but we can't do the traditional model all the time, right? So we need to be more creative about getting students these research experiences, doing it in the classroom, having projects where they can work at home, potentially. I've done that with a couple of my students. You know, they come see me once a week to tell me what they found by looking at the databases and things like that. So I think we have a way to help solve this problem, but faculty training, I think, is really a big barrier here that we need to think about. What professional development opportunities are available, and how do we make those professional development opportunities stick so that faculty feel comfortable incorporating this material into their classrooms. We are working on curriculum resources within NIBLSE. I'd also like to point you to CourseSource. Has anybody heard of CourseSource? Okay, a couple people. So CourseSource is an online journal for education. The major articles on there are lessons that you can essentially download all of the materials and then go into the classroom the next day and teach them. They are organized around different courses, and the learning goals for each course have been vetted by the appropriate disciplinary society. So the cell biology course is from the American Society for Cell Biology. Bioinformatics is ISMB. So we're, and NIBLSE too, actually. So we're working towards making more resources available in those 2 places. And as I said, Liz and Bill are working on assessment resources as well. Because you'd like to know, if you go to the effort to try and teach your kids some bioinformatics, that they actually learn something. So, okay. So again, our major goals, to establish this permanent network, I think we're well on our way. We have the core competencies available. Those core competencies are probably not etched in stone. They're probably going to be ones that we modify over time as the field matures. But it's a good starting place for thinking about how students should be involved in this now. We're putting assessment tools together that align. And again, Bill's going to talk about the dissemination of curricular materials later. So with that, I'd like to, again, thank the organizers for inviting me to talk, acknowledge my colleagues in this project. Mark Pauley, Bill Tapperich, and Bill Morgan are all here in the room. Liz Dinsdale and Eric Triplett are also part of the leadership team. We do have a steering committee that goes along with the leadership team, and I'm calling out a couple folks. Melissa Sayers was the lead author on the core competencies paper. Jason Williams is the lead author on the barriers paper. And Neil Grangenet also helped us with some of the initial analysis of the survey results. The survey was put together by folks at Georgetown Center for New Designs in Learning and Scholarship, Mindy and David, and our funding comes from the National Science Foundation. So with that, what I'm hoping is that we can take these great research experiences that are one-on-one mentored, but then think about putting them in a classroom behind a computer. So with that, I'll stop and take questions.
So it's really great to see an effort like this. It's really exciting. So I think from the very beginning of your talk, you point out one of the challenges that the students are not prepared to do advanced study. At the same time, they are not prepared for the workforce, for example, in the industry or any other setting. So I wonder, in addition to survey faculty, I think earlier this morning there's a talk about how biased we are. So I wonder if you have planned to survey the potential employer and also the students in a similar fashion.
Yeah. Yeah, I think that's a great point, right? We need to understand better what the workforce needs are, I think, especially around minority-serving institutions, because a lot of those students like to stay in their community and then give back to their community. So we need to make sure that they have opportunities when they leave community college or college to join the workforce. And I think that's an issue that a lot of people are trying to grapple with. In part, what we're trying to do with our next survey is ask that very question. One of the things that we're interested in is when we talk to the minority-serving faculty, can we get some information about places that their students can go work? I'll give you one example. I was on a site visit to Tulsa Community College as part of another group, and they're very interested in getting bioinformatics into their classrooms, and they're doing a lot of efforts in collaboration with the Oklahoma Health Sciences Center. But in Tulsa, there are 2 places where their students can go work that they do anything that's related to bioinformatics. So they have more desire than capacity at the moment. So I think that is a problem, yeah.
So thank you too for the interesting talk. I'd like to ask, do you have any data or plans to extend the survey outside the US? I mean in Europe, Asia, although I frankly think that the results will be more or less the same.
Well, we did have a number of people who were from outside the U.S. who answered the survey, but they were, we didn't have enough in any one place to really do much with those. I think the bottom line, though, was that even when we kind of looked at that, you're right, the answer was more or less the same. Yeah.
So I'm curious if any of the minority-serving institutions that responded to your survey were tribal colleges, and were there any mentions of cultural sensitivities or cultural relevance in your responses?
I'm trying to remember. Not very many, but in our next survey, we are trying to target them specifically. So Jason and I have had a meeting with stakeholders from some of the different communities, from some historically black colleges and universities, from a couple tribal colleges, from Hispanic serving institutions. And so that was one of the things that we actually talked about, was making sure that we're doing this in a culturally sensitive way so that we get the information that we need in a way that's going to in turn help them. I have a good colleague who teaches at Howard University in Washington, which is a HBCU, and her response is, involve us in the design. Don't tell us what you're going to do for us after the fact, right? Make us a real partner. And so that's one of the things that we're trying to be sensitive about as we move forward with the next survey. Thanks. One quick thing, if people have other ideas about the next survey that you would like to see answered, let me know, and we'll see if we can put them in.